So let's look at the pseudocode for breadth first traversal. I'm just going to read through it with you. So breadth first traversal, we insert the root. Then if the root is not null, so we just check if there is a tree, a binary tree exists. We return if there isn't one. Now we create a queue and we enqueue root into the queue. While the queue is not empty, we dequeue the queue. And then we output the node data. Now we always kind of check from the left. So we check to the left, node.left, if it's not null. So if the root, let's say it's M, the left root is F, then we enqueue that node into the queue. And if. Then we look at the right. If the right node, so the right of M is T, if it's not null, then we enqueue the node to the right. So we enqueue T. So we're enqueuing M's children. And then end while loop. And then end procedure. So it keeps going while the queue is not empty. It dequeue, it outputs it, and then it enqueue its children. So here it's where it's enqueuing its children. Until we keep going on this while loop until the queue is empty. This is another pseudocode that you could use. So this is probably shorter. So while current node is not node, I should say node. Print the current node. Then it checks on the left and queue the left node. It checks on the right. It enqueues the right node. And then it dequeues. So it keeps going whilst there is item in the queue. So key points to take away. So we use a queue, so first in, first out. We visit the node level by level. So we're going to process the left child first and then the right child. It's not recursive, so we're using a while loop. And sometimes we call it level order traversal. The common mistakes made in the exam is students thinking it's a stack, so they use the wrong keywords. They use the word pop. Remember, we are using a queue. Now, why is the dequeue essential? Now, the dequeue is essential so that we can remove the oldest node. So that's just to make sure that we're printing out our tree. And if we don't have the dequeue, then nodes will never be removed and we won't actually get to the end of the queue. So remember, whilst the queue is not empty, we won't be able to know that it's not empty because we never dequeue. And then the traversal will fail.